Hey kids, time for some chain rule practice. Do you like my little chain icons here, right? See the chain, chain, chain? We call this our chain rule extravaganza. Remember, the big idea behind a chain rule is when you want to take the derivative of a composition. And remember what a composition is. A composition is one function put inside of another function. So you are used to this box here is like your algebra 2 box, where here's two functions. I want you to take g of x and put it in place of f. So you look at f, here's its dependent variable. You're going to take x to the fourth plus 1 and put it into there, right? So the independent variable used to be raised to the 3/2 power. Now you are taking x to the fourth plus 1, those values, and raising it to the 3/2 power. So in this first box, I just want you to write the composition. So that would be not u to the 3/2, but x to the fourth plus 1 to the 3/2. Now in the next box, I want you to take the derivative of the function f with respect to the variable u in it. Okay, see, u is the variable. You're going to use your power down, bring 3/2 down, copy over the independent variable, subtract 1 from the exponent. Now I want you to do composition into the derivative. Into the derivative you just found, I want you to replace u, just like you did in the algebra 2 box. I want you to replace u with g of x. So you're going to have x to the fourth plus 1 inside the derivative. Now, remember what you did with the composition was that you put g in place of u, right? So I could say u is equal to x to the fourth plus 1, right? Because I put it in place of u. And now I want you to take the derivative of u, right, which is what we called, right, g of x is x to the fourth plus 1, but we put it in place of u. I want you to take the derivative of u with respect to x. That's what this is saying, right? Take the derivative of g, but we call gu, in terms of x. Now I want you to multiply these two boxes. The derivative of f with respect to u, you're going to, after you put our u is x to the fourth plus 1, multiply it times du dx. Notice the chain here, right? See my chains? I end up with the derivative of f with respect to x, which is 3/2 x to the fourth plus 1 to the 1/2 times 4x cubed. And of course, I would probably clean that up 4 over 2 is 2, so that would be 6x cubed times the square root of x to the 4th plus 1. The chain rule is a product, and it is a product of two derivatives, really, but it is one derivative, it is the derivative of the outside function with the inside function plugged in, multiplied times the derivative of that inside function. So let's repeat that here. Do the algebra 2 step, right? Just see what is the composition. The composition looks like tangent of x to the 4th, right? That's what my composition is. But when I want to take the derivative of the composition, really you have to consider the derivative of tangent, right? The derivative of tangent is secant squared. Now take that u and remember you're going to take g and replace it, right? That's what you did. We took g and we put it in place of u. Then what is the derivative of u, right? Remember, u is x to the 4th because u is what we took x to the 4th and plugged it in here for this u. So what is the derivative of g, or the derivative of u, since we replaced u with respect to x? C the chain, B the chain, multiply those together, and you are left with the derivative of f with x stuff in it. But it is a multiplication of the derivative of the outside function, secant squared, at the inside function times the derivative of the inside function. Okay, so you will never see a question presented like that on an assessment. I will just ask you for the derivative of the composition. But I could ask you a couple different ways. Look at this one here. They're giving me the derivative of a function f in terms of x. I'm sorry, they want the derivative of a function f in terms of x at a point. But they're telling me that I have f with the function, f with the variable u in it. So I can take the derivative of f with respect to u, and that's 2u squared. Now, I'm looking for, if I want df dx, I know that what I would like to do is this C the chain, B the chain thing. I would like to have df over du multiply times the derivative of that u with that, what I replaced, right? When I do a composition of a u expression in terms of x. And if I do that, C the chain, B the chain, I am left with df over dx. Well, look at what they've told me. I know what df du is. Df du is 2u. I don't know what du dx is because they didn't give me the equation u is equal to x stuff, but look what they told me. Du dx at x equals 2 is 6. What's the only thing I'm missing here? What is u at 2? Right, so negative 10 times 6, negative 60. Right, so the whole idea of the composition being a product of two derivatives, the derivative of the outside function evaluated at the inside times the derivative of that inside function. With respect to x, and then I get df dx. So down here, same type of situation, although here they're just trying to get you to see who would be, right? If I have a function in terms of u, but I want the derivative of the function with x squared plus 1 replacing u. So what is this asking me to do? What is the derivative of that function f with respect to u? Isn't that cosine of u? What is the derivative of f, the function f that they're telling me, with respect to x? This little f with respect to x. What is that? 2x. So what is the derivative of the function sine u with u as an x squared plus 1? Whoops, I'm sorry. This has to be a u, right? See the chain, be the chain. df dx is cosine of u times 2x. Uh-oh, that's too many variables to display. What do I need to do with this u? So notice that what I did, what I've kind of been showing is this way of, right, thinking of the chain rule as these df du's times du dx expressions. But let me go back to this problem and say, well, if you're telling me that this is u, I want into f, I want to put u, and you're telling me that, right, I could just do the composition first. And now I want the derivative of that. What is the derivative of this composition? I already did the composition. That's what I was trying to show you up here, right? If you do the composition originally, well, I taught you how to take the derivative of this. It's the derivative of the outside function. Don't touch the middle. Spit out the derivative of the middle, right? It's the exact same situation. It's just that AP really likes this. Hey, can you also look at this? And notice in number 2, they didn't give you the option because they didn't tell you what u is. You just didn't know what it was, but they told you what it was at a particular x, which is why you didn't care. Here, I can choose to compose and then take the derivative, or I can do my separate ones, right? What is the derivative of this expression with respect to u? Bring down the 3 halves. right? No spitting, no chain rule. But now take the derivative of u with respect to x. And remember from the beginning, u, what they want me to put into f is x squared plus 1. Cancel, multiply, and I end up with 9/2 u to the 1/2 times 2x. Simplify that, replace u. Or 9x times the square root of x squared plus 1. But again, if I gave you this problem, and I said, kids, take the derivative of that composition, you would write 9/2, don't touch the middle, subtract 1 from the exponent, spit the derivative of the inside, and you would get the same thing. Let's do the last one. Right, remembering what my u is. Let's do this both ways. Take the derivative of f with respect to u. Take the derivative of u with respect to x. So the derivative of f with respect to x is the product of so that's 2u minus 1 times 2x. But what must you remember to do? Can't have all those variables floating around. Clean that up a little. Now, if I try to do this one, right, normally, if I went ahead and did the composition first, this would look like u squared minus u, right? And what would I get? I would bring down the 2, copy over the middle, subtract 1 from the exponent, spit out the derivative of the middle, take the derivative of x squared and the derivative of 1. Are these two things the same? For x times x squared plus 1 minus 2x. Think you can factor the 2x out of that? What are you going to get? Woohoo! Couple more. Given u is a function, right? U's name is g of x. Find the derivative of a composition. So again, I have this, because they've given me all of this, I have a choice. I can do the composition first, then take the derivatives, or I can take the separate derivatives and multiply. Either way. So let's do it way one. Do the composition first. F of g of x is sine of 2x plus 1. The derivative f prime of g of x is the derivative of sine. Don't touch the middle. times the derivative of the middle. Second way, take the derivative of the given f with respect to the variable you see. Take the derivative of g, which is called u, with respect to the variable you see. Multiply the separate derivatives, making sure that you have the chain to connect them. But then don't forget you need to replace. Right? Sometimes, so the problem with sometimes with students is when you give them two ways to do things, they'll pick their favorite and they'll say, I'm only going to do it this way since I get the same answer either way. Don't forget AP sometimes forces you into into both. And you are going to have to do the derivative of a composition this way, where either you're doing the composition or they've already done the composition for you, but also you're going to have to do it this way. So let's practice this last one. If I do the composition first, ugh, I got to do the quotient rule. Hey, I wonder if doing the other way would be faster. I don't know. Let's try. What is the derivative of f with respect to u? Well, gosh darn it, it's still a quotient. But I might want to do, whoops, that's not what the derivative is equal to. Silly. I'm not working with cosecants now, am I? Because think about what the derivative of cosecant is. I'm working with just u's. So the quotient rule never changes, right? It is the bottom function times the derivative of the top, which is just 1, minus the top times the derivative of the bottom, which is also 1, over the bottom squared. So look at what this looks like. U minus u goes away. That's df du. What is du? Because remember, u is equal to g of x. What is du dx? The derivative of cosecant is negative cosecant x cotangent x. And now I'm just multiplying these two together, right? df du times du dx is df dx, the derivative of the composition with respect to x. And what is that? Negative 1 times negative this gives me positive that. Over u minus 1 squared. But what is u? I claim that while I still would have to do the quotient rule, doing the quotient rule the second way, where you're taking the derivatives of the pieces and then multiplying them together, made my work a little easier, right? Again, still doing the quotient rule, but doing the quotient rule this way wouldn't have been terrible, but I claim the second way is probably a little cleaner. All right, so that's it for our chain rule extravaganza. In our live session, we'll do a little bit more with both the chain rule and implicit differentiation. I will see you then.